Hello everyone, thank you for joining us today. My name is Laura Smith and I will be your host. Welcome to the Network's webinar, Innovative Manufacturing. This webinar is brought to you by Maytech Networks. Networks is a part of Maytech, a member of the Division of Academic and Student Affairs at the Maricopa Community Colleges, and funded in part by a grant from the National Science Foundation. This webinar is being recorded and we will provide you with instructions on how to access the recording and slides as soon as they are available. Let's get started. If you're familiar with using Illuminate, please raise your hand. Okay, I see that some of you are not, so we'll quickly go through some of the Illuminate features. This area right here is a screenshot of our Illuminate session today. Notice the whiteboard area. This is where the presentation slides will be displayed. To the left of the whiteboard is the chat box. Feel free to type in any questions in the chat box to this room so that others can follow along. Above the chat box is the participants box. This shows a list of everyone that is joining us today. You may recognize colleagues, and it's okay to send them a message, but be aware that the moderators and presenters do see all messages typed into the chat box. Another interactive feature of our webinar today is audience polling. Notice the poll buttons above the participants box. We will have the opportunity to do a poll today, and when we do, we ask that you choose the correct answer button located right above the participants box. Below the poll buttons are emoticons. This is another way for you to interact with the presenters. Feel free to use these throughout the presentation. All right, we have a great presentation today, and moderating our presentation is Michael Lasecki. He is the Executive Director of Maytech and the Principal Investigator of Maytech Networks. Mike, welcome.
Thank you very much, Laura. I'm pleased today to be part of this webinar. And our presenters today include Eric Wenham. He's the Account and Marketing Manager at Engineering and Manufacturing Services, Inc., and that's in the Tampa area. And our colleague, Marilyn Barger, who is the Executive Director and Principal Investigator of the Florida Advanced Technological Education Center. So Eric, welcome. Would you tell us a little bit about your background?
Yes, thank you, Mike. I appreciate it. Yes, here at EMS, we do offer a variety of products as well as services with utilizing those products. And they all deal with rapid prototyping and product design and development. Let me go to the next slide.
Okay.
We were founded in 2001, and our headquarters here in Tampa, Florida, but we also have offices up in Detroit and Atlanta. And every year we've seen a growth. It's been, with awareness getting out there, becoming more popular and a lot more demand for our services and also our products. We have well over 25 years in design and engineering, and mainly industrial mechanical engineering. And we primarily just focus on 3D scanning, product design, and rapid prototyping. Today I'm here to talk to you about 3D scanning, product design, and rapid prototyping. All can be used on one project, or you can, depending on what your needs, might only need to use one of these resources. But usually, typically, on some projects, we can combine all three of them and get a product created and ready for manufacturing. First, we're going to talk about 3D scanning. Some of you may not be familiar with what 3D scanning is, and basically what it does is there's a couple different types out there, and it has a measuring device that you can collect data. So an object out there that doesn't have any CAD, maybe because it's so old or it's protected by a company, but you see some modifications or additions that you could improve that product with. So you need to reverse engineer it basically. Now you can use one of these types of technologies to collect the data to do a reverse engineer and CAD model the part. There's white light, laser, touch, which is also CMM, and long-range scanning. So depending on your needs and the part and object that you're trying to reverse engineer or model, you can basically reverse engineer anything with any of these types of technologies. Here at EMS, we primarily focus on laser scanners. We have a variety. The Surphaser is a long-range scanner. The Z-Scanner is a portable handheld device. And then we also offer laser scanners by Konica Minolta. It's a stationary device that you basically put an object on a rotary table and can scan that part and auto-align all the data. Once you collect all your data, it's just point cloud data. There's no intelligence behind it. So now you need to bring it into a software to basically reverse engineer it or make the scan data watertight so you can make a surface model or a polygon file. And we use here RapidForm. It has some very similar characteristics to SolidWorks, and that's what we also CAD model in. So RapidForm is a very powerful tool to reverse engineer scan data. It also has another application to inspection reports. So people, when they need to compare the first article of production off the original CAD to make sure that the tooling was done correctly, they can scan the part and bring in the original CAD data and now do a color mapping of where parts and areas deviate from the existing CAD. So basically, you have your object that you want to capture data from, and depending on what scanner you select, with the Z-Scanner, you use targets to reference the area, and you can basically pick up that object, hold it in your hand, and use the handheld scanner and scan all around it and collect accurate data to reverse engineer. Now, this sculpture would be pretty hard to make a parametric file out of, but you can make a nice watertight polygon file to maybe you want to make some slight modifications, smoothing out the face a little bit more, or make some small cuts or holes in there. But if you wanted to scale this mask up or down, and for rapid prototyping, you'd be able to do that with this type of part. Otherwise, you would need to get more of a mechanical part to do reverse engineering, where it would have more intelligence behind it with dimensions and individual faces to move and modify. So these are your scanning output options. You can do a polygon file, which is a bunch of triangles. You can make a surface model. Doesn't have any thickness to it, just the surface of the actual model. Or you can get a more of a mechanical part and put true dimensions behind it. So there's many ways or reasons to be using a 3D scanner. As I said earlier, we do a lot of military and defense work, and either the original manufacturer doesn't have or won't give out the CAD data, or it was created before 3D CAD modeling was available. So there's no data behind it at all. That's one reason for using a scanner. There's other channels that we focus on as well with, as I said earlier as well, inspection and also forensics.
Eric,
do you have any questions?
I want to remind the folks that if you type your questions into the chat window, that we can see them. And I have actually a couple of questions from the participants right now. On these scanning things, like when that guy's head was there, if you're moving the scanner around, do you have to I mean, you just move it around arbitrarily, or do you have to set up a coordinate system that the scanner moves through? I mean, how does it know where it is? You know what I mean? I'm not sure I'm phrasing that question very well.
Yeah, no. Well, again, yeah, it depends on the type of scanner you're using. For instance, the one with that's a handheld by Z Corp, it remembers. You use these reflective targets, and you put it all over the part.
You paste on, like you paste them on. You paste on, or
yeah.
Oh, like a sticker, yeah.
Yeah, yeah. So you stick them on the part, and it now has, it's as long as it can see 3 targets, it can remember where it was. And the scanner can only scan at a certain clearance from the part. So you're not going to be scanning right next to it or too far away from it, because the lasers reflect back the data, and it knows the distance of that area that it's hitting.
Yes. You know, I had one other question from a participant, and thanks for that answer. They noticed the pricing on those scanners. Well, some were more than others, but none of them were like particularly cheap. Is there a level of scanner that can actually be brought into, say, a college lab or something? You know, that's something, let's say, a 5K-ish. Is that even feasible, or do you really have to talk about quite a bit more than that?
Well, yes, there are other types of scanners out there that are, around that price range or below. Is it going to report back accurate data?
Right, right.
Or how long? There's one out there called the Next Engine, and I believe the price level around it is $3,000. But is it first understanding schools want to get this technology in place, but to me, it's more important to show relevant technology, so that when a student does go out there to apply for a job and they do have the same sort of scanner that he used in the classroom, it helps out a lot, because they've past use with it. But also those lower price point scanners, they operate differently, and they also aren't as accurate as some of these commercial scanners are. Yeah.
That really makes a lot of sense, yeah. Good. I've got another question, but it's more about the manufacturing side. I'm going to hold that one till our next question break, so why don't you go ahead then?
Okay. So this is an example of one of our scanning projects. The nice thing about this, and as you'll see, we can use a wide range of scanners. One scanner is not going to be able to do maybe a complete job, depending on how large the job is. For instance, this is an LAV military vehicle that we had to scan the entire inside and out of it. And this is the Vivid 9i by Konica Minolta. It has a larger scanning window, so it can collect a lot more data at once. But in some areas where it's very tight and where this wouldn't be able to fit inside, we had to go and use the handheld. Now you can see all the targets that are all over the part. The Vivid 9i does not need that because it's stationary. It's scanning and not moving. Where this needs the targets because it's moving around. So this, so now we can intermix all the scan data and align it so that we have a complete reference to model after. So, and then this is modeled. So now they have all the necessary means. This was, I believe, for a simulator that they know everything about the parts. If they wanted to mount something on it, or if they wanted to make some modifications, they have a complete model where they can continue to make additions or modifications to it.
You know what? We've got a poll now, and we want to test our participants, Eric. So here's the question for those of you folks on the line. And remember to respond by clicking the button way at the top of the page where it says A, B, C, D, or E. And here's the question. What percent of all new products, I'm talking about every new product, go through at least one scanning or rapid prototyping stage? You think it's something like 32% or 73 or 86 or more than 90%? So please click your answers right now, and then in a few minutes we're going to publish the requests. If you don't know, take a guess. don't type your questions in the window. Click on that button way at the top. That's it. And I'll give you another, I don't know, 8 seconds. How does that sound? Dun, 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 dun. I should play my Jeopardy, hum my Jeopardy tune or something like that. Okay, Laura, let's go ahead and close the poll and see what people think. So a lot of people think 50% or so. You can see the answer. Well, it's pretty astounding, and I got this information, Eric and I were talking about it. I got it from a trade journal. It's more than 90%. The correct answer is E, and nobody got it. More than 90% of all new products go through at least something. Either they're scanned or they're doing RP step somewhere along that product development thing. That's pretty amazing, isn't it, Eric?
Yeah, no, it's I mean, that's what we do on a daily setting here. We get a lot of large company or small inventors ideas and CAD models and at least rapid prototype for them so that they can confirm that the design is accurate into their needs before they go into the next process, which is the tooling stages.
Cool.
Yep. So next is a video of the scanner, the Virtuoso by Konica Minolta. It's just a quick video to show you kind of the scanning and the output that this scanner can do.
Okay.
So there you are. It's a quick video
cool.
to show. Yeah, it's a quick video to show kind of the level of detail that the scanners can pick up. Definitely to replicate models or scale them up or scale them down. It's pretty helpful. The next topic that we're here to talk about is product design. And a lot of things come up when you start off with your initial design, and everyone can think of something that they always dreamt of bringing to reality, but not many people have been able to accomplish that. So there's a lot to think about when you're coming up with your design. It's not just okay, this will work and this will benefit me, but how will it serve a purpose, and what steps are needed to take to get it from a napkin sketch, as we call it, to on the shelves. And a lot of people have to think about this, and because there is a lot of steps involved in order to bringing your dream to life. And and this is why we're here. We help a lot of people and consult them through the steps and what to expect, and make sure that they're prepared before they start, just because there's a lot to it. So one of the things we say is do it early, do it often. What I mean by that is design engineers influence about 70 to 80% of the product's total cost. They are the ones that are going to be figuring tooling methods and making sure that your tooling costs are down low as possible, but also the amount of material that's going to be consumed, what material. So they drive about 70–80% of that product's total cost. And so you want to work with your suppliers. You really want to get everything that you foresee out in the open and do it over and over and over again. As that last poll question was, how often does a product go through rapid prototyping or 3D scanning? Well, rapid prototyping very often. Usually I'm 3D printing with 5 to 6 different iterations on a product before it's complete and ready for tooling.
Eric, I had a question for you. I'm looking at the graph there. You say influence 70 to 80% of a product's cost. I guess you're not saying it contributes to the cost. Maybe that's what that diagram. What are those 2 bars there that I'm looking at? Oh, I see.
Yes, I'm sorry. Yes, yeah. So right here, you can see it's a fraction. The cost isn't really what's the design engineer's time isn't really that expensive, but it's the influence of the cost. Is with the engineer.
But it's a useful slide to show my students, because then I can reinforce this is like one of those, what do they call them, Pareto type charts, and I can, this would be good to use in the classroom. Well, thanks.
Yeah. So there's a lot of CAD programs out there. A couple of the main ones are SolidWorks and Pro Engineer. Another one that we're here to talk about today is SpaceClaim. And that's the next generation of 3D CAD, and it's direct modeling. What I mean by that, there's no history tree to reference, and it's basically you're working on the actual object instead of doing history tree. So there's with this program, it enables you to do a lot of things fast and easy. Like, for instance, converting 2D drawings into 3D. If you go to SpaceClaim's website or the YouTube channel, you'll see a lot of videos, and one of them is a 2D to 3D conversion, and it's so fast and easy that it's pretty impressive what it can do. A lot of other things to do with this is concept modeling. It's very quick and easy to just develop your design and so others can see it without having to have to describe it or draw it by hand. You can very quickly make a quick concept, and it might not be accurate right away, but at least get the point across of what you're trying to do. The power behind SpaceClaim is basically behind 4 tools: the pull, the move, the fill, and the combine function. Right here is going to be a quick video, and then we'll kind of demonstrate SpaceClaim's use and capabilities.
Top 10 reasons to use SpaceClaim for companies. Watch closely, or you just might miss something. Number 10. With the ability to reuse edges and faces, you can change your concepts on the fly, whether freeform with specific dimensions, change your model any way you want. Number 9. Need to move multiple faces at once? Not a problem with SpaceClaim's Move tool. Or make drastic changes to edges and faces that you just can't do in a feature-based CAD system. Number 8. Removing complex geometry used to be problematic until SpaceClaim developed the Fill tool. Now you can do feature any model faster than ever. Number 7. Have you ever needed to tweak a model or make a one-off change only to find out that it will take hours in your traditional CAD system? SpaceClaim lets you do those changes and more in just seconds. Or have you ever had features from multiple models that you need to somehow merge together? With a simple tool called Combine, you can save hours in precious modeling time for reusing your design. Number 6. With SpaceClaim's engineering notebook, you can fully convey your ideas in a 2D fashion. You have complete dimensional control and an array of different view types to illustrate your concepts on paper. But the best part is, you're still working in 3D. Number 5. No more messy history tree when it comes to sheet metal. Create multiple flanges and move them where and when you want without constraints. Corner treatments giving you problems? We've taken care of that too. something with 2 clicks on your mouse. Flat pattern is right in front of you. Number 4. Why run through concepts in a detailed CAD program? SpaceClaim lets you try out design scenarios and gives you a powerful tool to convey them to anywhere. Compare the ultimate new models with is-was dimensions, and you'll never miss a change. And since pictures are worth 1,000 words, you can easily convey your changes in color. Number 3. Have you ever opened a model just to find a collection of faces instead of a solid? Well, SpaceClaim has a set of automated repair tools to turn dirty geometry into something useful again. Whether there's missing faces or gaps, these tools save you time recreating the model from the ground up. Interoperability has never been this easy. Number 2. Bring the model to life with a powerful tool called KeyShot. With this simple user interface, you'll be surprised how easy it is to make a photorealistic rendering in seconds. Change the appearance, color, even texture of models while setting the backdrop to any photo you want. It's just another tool to give you to help you win bids and proposals. And the number 1 reason to use SpaceClaim is every engineer can finally innovate, design, and analyze faster than ever before. With unparalleled simplicity, anyone can use this powerful tool. Try it for yourself and see.
So as you can see, it's a pretty powerful tool. I'm not going to say that it's a replacement tool for SolidWorks or Pro E. It's just another tool for your toolbox, basically. It's going to help speed things along and make things, any sort of modification or adjustments that you need to do very, very quick. So, a couple things that the SpaceClaim users use it for is obviously manufacturing and concept modeling. Another one is bid modeling, and there's many different types of customers for this type of product.
What's CAE, Eric, on the bottom there?
That's what is that? That's
Computer-aided engineering, maybe?
Yes, you're correct.
That's a guess, but it sounds right, doesn't it? Yeah.
Yeah, computer-aided engineering. You're correct.
Yeah, good. Okay. Put you on the spot there.
Well, I was wondering about if the people were wondering about bid modeling. That's something that is you want to quickly mock up a part or an assembly to show a prospective client, or do a quick analysis on the customer's geometry to verify it before he can place her or his bid, basically. Mm-hmm. So it's very fast at doing that.
Cool.
This is a quick example of a project that we did here. A high school student came to us with a working prototype of a accessory for drumsticks. And basically what it does is it attaches it to your finger so that you're not dropping your drumsticks during a set. And he showed us a working prototype. It was kind of rough, but we got the point of what he wanted to do, and basically got it and simplified it and made it very easy to manufacture. And now he's distributing all over. So it doesn't take a special person to be able to do this. Anybody can do this. You just have to be designated and devoted to it, and just be ready for some bumps in the road. But it's really rewarding once you get your product out there.
For the participants, right there, it's a good time to good opportunity to put questions in the chat window, and we do have a couple that I'd like to bring up to you, Eric. Let's suppose I'm sitting here in Phoenix, Arizona, and I've got one of the design programs, and I draw up my part, and actually I have an idea for a small medical device. Not device, it's a diagnostic tool, and I need a housing for it. It's got to look clean. I want it to have sort of a medical look for it. So I sketch this up. Can I literally email that to you, or if it's a big file, have you download it from somewhere, and you produce the part or some other vendor and send it back to me? Is it that simple, or do I need to do more? Like you mentioned, this drummer kid, I don't mean he was a kid, but he came in and talked to you. Do I have to actually come in and talk to you, or can I just say, here's the file, give me the part?
No, not at all. We do projects all over the world, actually, and have customers all over. So especially depending on where you are in your project stages. I get a lot of plan sheets, or I get customers that fax me just some napkin sketches that they did themselves.
Yeah.
And we can take those and be able to produce a model and even share it with you. We can set up go-to meetings and share my screen, or I can even send you an executable file for an e-drawing where you can review it yourself.
Oh,
so
not bad.
Yeah. Yeah.
What about the SpaceClaim? You talked about, is there an academic provision? Some of these other softwares have student sort of pricing. Is there an academic license that's available that you're aware of?
Yes, there is with SpaceClaim. Students can purchase it for $50 a seat.
How much is it again per seat?
$50.
Is that a minimum number of seats I have to buy? Sorry to ask these questions, but
no. Students, they can just if they want it for themselves, it's just $50 a seat.
Wow, that's really not bad.
Yeah. No, and it's not bad to get it into schools either, price-wise. SpaceClaim really wants to start working with the education sector, and depending on how many seats you need, they'll put together a package for you. But very affordable. I'm thinking, last remember, I think 25 seats was going to cost a student $2,000 or less.
Mm-hmm. Or institution less. Oh, so that price dropped to 40 then on that level. So there's a quantity discount.
For when you're buying that many seats, if it's
sure.
going to buy it to roll out into the
not bad. That's really not bad.
No.
I have one other question that came in. I'll paraphrase the question slightly, but you could see things like people who do custom art objects, maybe running these through a stage like that. I'm not sure they always do a CAD drawing of their custom art project, but maybe they could use a scanner and then see how this might want to do it.
Yeah, and we do that a lot. We work with a lot of different artists, and one in particular, he likes to scan odd objects and then scale them up or down depending on the size of the original object.
Oh yeah, and scaling, yeah.
Yep, yeah, and then and then we rapid prototype it for him.
Who do we talk to about getting one of these academic licenses for SpaceClaim? Do we call you? Is there a website? How do we do it?
Yeah, I can put you in the direction of the individual licensing, or if it's for for a school, I can also help you out with that as well.
Do we contact you directly?
Correct. Yeah.
Okay, because I know we've got your contact information. No, we've got it towards the end. It'll come up towards the end, or Laura can type it into the window. Right, that's good. Oh, I have one last question here. I can't resist asking it because two people already asked me the same sort of question. It is, what's your sense of how do people actually use this for production? I mean, sure, you do it for prototyping, but let's suppose you have a small production run. Is it worth it making that stuff by an RP step? I guess it would depend a lot on a lot of things, but do you have a sense of how many people are going towards literal production of things as opposed to just prototyping? Yes.
In fact, we had a customer that actually bought a printer due to his part was able to be toolable, and what I mean by that is making a steel mold, tool for an injection molded part. But it was going to be it was going to be a lot of money. It was less than a printer, and the amount of parts he needed, or wouldn't justify the cost of doing a tool.
Yeah.
So he designed the part and now rapid prototypes it, and that's a finished product. There are other ways of doing small low run production as well. It's called an RTV mold. So what I would do is produce a high quality, high resolution RP file out of like SLA.
Yeah.
Very high resolution.
Yeah.
And I would then put it in a silicone mold. And now I can get roughly 25. Yeah.
Before the mold.
25 copies of it.
Yeah, before the mold, I don't know, gets bad or whatever they call it. Yeah.
Yeah. So,
all right. Neat. Take us forward.
So yeah, we'll move on to rapid prototyping, And yeah, there's many different reasons for it. There's a lot of different technologies out there. Started in late 1980s was when the first technology started coming out. They've obviously improved and made alternative methods. And so there's plastic-like material to a powder-based material. And we'll go through some of those in just a moment. Here at EMS, we're a 3D systems dealer, so we carry their line of printers, and they are the broadest range of printers available on the commercial side. They also have personal 3D printers as well. As you can see, price vary greatly from $1,300 all the way to almost $250,000. So depending on and they all vary on the material that they use, the way they produce the parts, and the resolution and size as well. So we're going to walk through the process real quickly on the Z Corp printers. Again, Z Corp was just bought by 3D Systems, so now it's 3D Systems printers. So basically, you take your CAD file, and with Z Corp, because it can do true color, it's a powder-based material. It builds at 0.004 of an inch layer thickness, and it spreads that thin layer of powder across the build chamber, comes back over with a print head that uses HP print heads, purges out the ink, and then brings in and just uses the print head as a vehicle, and applies binder that way. So it takes your CAD file, your STL, Vermal, or 3ds supply file, and slices it up to those 0.004 of inch layers. And whatever's at that cross section is going to get binded to the previous cross section, so forth and so on. The bin obviously drops as each layer is added, and builds vertically about a vertical inch an hour. So you bring your CAD file into the software, it slices it up, and then it starts printing it. And here's one layer being printed. Again, because of the way it uses HP print heads, it can print true color. So that's an image that's going to be put on this camera, and you'll see in a moment. So as I said, the bin drops and keeps spreading that layer of powder across the entire build chamber, and then the part you would be encased in powder, and you pull it out, and you recycle any of the unused powder. It's recycled and put back in the hopper for the next build. So there's no waste material. Again, here is getting all the excess powder off. There's a depowdering station. It has a downdraft, so that gets all the excess particles back through a filtration process and back in the hopper for the next build. Once your part's fully depowdered, then you submerge it in a super glue or paint on a 2-part epoxy. That's what gives it its added strength and also really brings out the color. And here's your finished part. So pretty quick, pretty easy, pretty fast, and it is the fastest and least expensive prototyping process out there. It's about roughly $350 to $450 a cubic inch.
Eric, we're having a couple of people, including me, are having connection problems. Apparently there's some sort of internet glitch that's going on somewhere. I don't know exactly where it is. It may take a moment for a couple of us to get back on. But while we're doing that, you essentially, they're dipping this thing in super glue, or they're pouring super glue on it. I mean, that sounds pretty weird. That's actually what they do.
Well, yeah, and it's not. We have these just in middle schools and high schools all over. It's very easy to use. You use protective gloves, of course, when you're using super glue, and basically the super glue reacts with the powder. It's engineered to react with and solidify right away. So basically when I have a part and I submerge it into the super glue, it's for a second, if that. dab off the excess with a paper towel, dab off the excess super glue, and a few seconds later it's ready to be handled. It's dry and
amazing.
No problems to work with it. Yeah.
Pretty interesting. Okay, why don't you go ahead? It's it looks like it might only not be me, it might be others too that are having a problem with connection. But why don't you just keep going ahead? You're still connected to the system, right? It looks all okay from your side?
I can't see any participants.
Right. Okay. Hold on just a second.
Okay.
Okay, so why don't you, are you able to advance your slides?
I am, but it's saying I have a connection issue.
Yeah, yeah, I'm showing the same thing here. Why don't you hold on just for a second and let me see what we can do here. Ladies and gentlemen, we're just troubleshooting a problem. And then what we'll do, Eric, if we can't get all of this back together, we'll just continue and we'll make the the recording available so that people will be able to do it. I'm going to try logging right back in now, just for a second. One of those network things, huh?
Not network,
okay.
network.
Yep. Oh yeah, excuse me. Thank you, Laura, for adding that in. Laura, do you have a connection?
I do.
Okay. Hold back in. Okay, I had to remember the password there for a moment. Okay, good. Thank you, Eric, for your patience.
No problem.
Okay. Well, Eric, are you able to, you can't really see the next slide, can you?
I'm not sure if I am. Laura, can you see if I'm advancing or not?
No, Eric, I show that you've been dropped also.
Okay.
So you might want to try to come back in. You also have your a hard copy of your slides, I believe, or the PowerPoint.
Mm-hmm.
Maybe
let's go from the, if you can talk from your hard copy, and we'll just continue from there.
Okay.
Hello, everyone. Sorry, we've been having some technical issues. Our executive director would like to explain.
Well, thank you very much, Laura. It seems for those of you that are still on the audio version, for example, myself right now and the other two presenters don't have a connection, and apparently that's due to the Illuminate internet connection from their central server. That's the message I got for them. So we don't see that we have an option here except to reschedule this webinar. We'll contact those of you who are still on, who are still listening, by email, and send you what we have, the information that we have, and the new schedule for this. Laura, I think that's our best shot at this point. It doesn't do much good sitting here waiting for them to restore their connections.
And I see several of you have come back on. We're up to 8 audience
we are?
members now, but we thank you and we apologize, and we'll contact you.
Hold on 1 second. Oh, I'm back on now.
Yes. And Eric?
Wait a minute. I've got 11. Are you back on, Eric?
Yep.
Wait a minute. Are you on, Marilyn?
No, I'm not.
Why don't you try logging back in and then we'll keep going. I see Maria saying that the audio is back as well for those of you online. Well, looks like we're going to continue.
Okay.
Okay, we're back. Eric, where did we leave off? I was talking to you about superglue.
Yeah. Okay. So the post process is very easy and not dangerous, and you don't have people gluing their fingers together. Again, you're supposed to be wearing gloves when handling the parts anyways, and but very nice. Again, the printer builds about a vertical inch an hour, and with the material costs being $350 to $450, $3.50 to $4.50 a cubic inch, it's the least expensive option as well. So with Z Corp, you can do in the classroom setting a lot more students' files faster and easier. And whereas where the other competitors' technology costs 2 to 3 times more than that, and plus their build speed is about maybe an 1/8 to 16th inch an hour. So you're not going to be able to produce as many parts at a time, and it's going to take a lot longer as well. So here, talk about different industries that use it and the uses for it. And as you can see, a lot of it is concept, design, and iteration. You keep going back to the drawing board and produce your parts after each iteration and confirm that the part does what it's supposed to do and all the intent is there before you go to the manufacturing stage, which is doing the tooling. Tooling is very expensive, and you can't, once it's done, it's done. You can't easily modify the tool if things aren't, for instance, if you're designing an enclosure and need to make sure all electronic components fit inside of it, and you made your tooling and all of a sudden not all the internals fit inside of it, that tool is now junked and a waste of money and time. So that's one great use for rapid prototyping. You can get functional models. Again, there's a lot of different processes and material with each process. So if you need a silicone part, you can prototype silicone parts now. If you need a hard plastic durable part, you could do that as well. If you need ones that are withstand certain temperatures, there's material for that as well. And then also fit assembly. Making sure, again, as I was saying before, using the enclosure part, making sure that everything fits and works as it's supposed to. Here's some examples of concept models. Quotes and proposals. Print out a part, and now you can physically see areas that you need to pay attention for on a bid. It's great to show your manufacturers the finished product so maybe they have a better idea of how to tool it. If you wanted to make low run production parts, RTV mold, this is where you encase it in silicone, and now you can use urethanes to reproduce the parts.
Oh, Eric, I want to design a new iPad sleeve, then I'll be famous and wealthy.
Yes, correct. We get a lot of those. We do a lot of 3D scanning of the iPad.
Interesting.
Those cases around it. Yeah.
Interesting.
Yep. Let's say you did an inspection, and this is where I was telling you we can compare the first article of production. We 3D scan it, and then compare it to the original CAD model, and now we can show where parts are dead on or where it deviates. And this is the color mapping that you can print out on a part to physically see it. Very helpful. Functional parts for testing. This actually is on our shelf. It's on and is on the store shelves as well. But we helped this gentleman create the marshmallow shooter, and it actually functions like the actual manufactured part does. Assembly. Architectural models are very helpful. You don't have to spend time gluing particle board and a foam board together to get your. You can CAD model the structure and print it and add texture wraps and color to the model, so it'd be a lot faster and cheaper than having someone manually create architectural models. Tooling. Thermoform molds, vacuum forming. GIS models, ergonomic models, making sure that the part really, if it's a handheld device, make sure it really feels good in a person's hand before you go to the manufacturing stages. And packaging. Oh, also sales and marketing models. Take down scaled models and show them to your customers. Obviously, you can't create around large turbines or heavy equipment machinery. This is a way to show your clients or your potential clients your models as well. And you can get real nice appearance models done with rapid prototyping. The technology has grown since it first came out, and it's incredible the resolution that you can get off these parts. Again, we're a 3D system, so we have the broadest range of printers. Different materials, different build speeds, different processes, so we can cover basically any sort of type of prototyping need possible. And here's a quick video demonstrating basically everything that we just spoke about, from 3D scanning to reverse engineering down to utilizing the printer.
We need extremely specialized tools, but with high tech comes higher risk. Using any of this unconventional gear can be a disaster. So we're going to need even more extraordinary technology. A way to make unlimited replacements. If we had a science fiction replicator, theoretical physicist David Kemp has found a company that replicates tools and pretty much anything else you can imagine with a 3D copy machine. We live in Burlington, Massachusetts at the Z Corporation, where they've developed a new technology that's similar to those replicators you see in sci-fi movies. It's called 3D printing. I'm here to find out if they can 3D print my crescent wrench. We're one of the world's leading manufacturers of three-dimensional printers. Everything on the table in front of us is printed in one of the machines behind us. Printed, yeah, okay. Most printers will print things in 2 dimensions. A 3-dimensional printer will then take that to the 3rd dimension and make it something you hold in your hand. Okay, I don't get it. And that's just an example of the complexity of the thing that you can make. It moves and it's printed all in one piece. This came out of a printer just like this. It came out of a printer just like that. What is the material that makes this thing? Specially engineered composite material that starts out as powder, then we add to it a binder material that solidifies those powder particles together. These materials are the company's own secret recipe, a unique concoction not used anywhere else. This is one of our three-dimensional printers. This printed inside this machine injects specific fluids with coloring different parts. Yeah. But we also have a printhead for printing our binder materials to solidify the parts. Yeah. The powder is the paper and this final stuff is the ink. And this tray here that it prints on will actually go out into the machine to go to that 3rd dimension. Okay, I would like to see that. Could you reproduce this print? First thing we do is scan it. All right, do like that. The scanner inputs every facet of the wrench into this computer, creating an image that will be sent to the printer. Oh, that is cool. How accurately can you measure the shape? The accuracy is within 40 microns. That's like a human hair width. Absolutely less. That's incredible. All right, so the wrench was scanned. Here's the wrench that you did. Okay, you can make that ring red. Sure. I want to select it and paint. Now that piece is red. I see. It's just that simple. We're ready. We just go down to hit. All right, Dave. Everything's done. We'll take a look at the wrench. Okay. I don't see anything. It's in there. Just reach into the powder and flush. Okay. Holy cow. Wow. Yeah, there's a real wrench right there. Oh my God, you printed it. Yeah, it came right out of the powder. That's amazing. So all that's left to do is blow off the rest of that powder. That is cool. Yeah. A color 3D printer. I'm freaked out by this. It doesn't make sense. I'm holding this thing as moving parts and it just came out of a printer. Wow. Isn't that easy? This changes everything. So how strong does this thing get? You can get strength just by using this full extra resin. We can actually use it as a tool. Absolutely. Okay. Let's see if this really works. My little foot hard. Go for it. This is your little wrench. Okay. What do you think? Wow. It's a real tool. Yeah. Holy cow. We just printed it an hour and a half ago. That's nothing but a bunch of powder and binder and box and powder. That is incredible. It's a real tool that you can use for functional tasks. So going into space.
I can't see the slides though.
That's right. Anything with a tool. if you lose your tool in space, you can print out.
Oh, I see.
You know, Eric, there's a friend of mine, and I remember him sending me the link to this video. He said, "Did you see this crescent wrench they made?" And it really circulated the internet quite a bit when that happened. Anyhow, it was pretty interesting.
Yeah. It's we got a lot of customers from that video as well.
Yeah, interesting.
Yeah.
Okay, what's the next here? Question answer?
Yes, correct.
You know, I have a question for you, and then we're going to move on to, in the interest of time, to our next one. So I'll limit to just one question at this point. You know, if you've dealt with academic institutions for these things, you have any sense of where there are some research opportunities in this area? Let's suppose I'm from a four-year university. I'm in engineering. Do you have a sense of where a place might be that you know of that people have gotten money from grants for this sort of equipment? Do you have any ideas about that?
Not necessarily. I mean,
you may not. You know.
No, I don't really know where you know, where people are applying for grants and when it's received.
Yeah. Okay.
We do have a lot for some of our printers. They are on the GSA, and we do have a lot of people writing grants for around our printers, but that's or scanners.
Okay. Well, we're going to research that a little bit and see if we can provide that information back to our participants. You know, Eric, I wanted to thank you for your part of the presentation, and
thank you for having me.
Yeah,
really appreciate it.
I'd like to stay on the line a bit, and as we go into Marilyn's presentation, there may be some things that we could do. Let's take us right to the next one. Now, Marilyn, you're on the audio, is that correct?
Yes, I am.
Good, and I'd like to work with you on your presentation, if that's okay. I can do the advancing and things.
Okay, so good afternoon, everyone. Sorry about these technical difficulties again. I'm actually not connected, so hopefully Mike will be able to work with me and get through the slides. So we spent some time now listening to Eric talk about the technologies that are out there for the in this area. And one of the things we've been doing at Slate was developing a program and getting it into place that teaches students, a technical program at the community college that teaches students the skill sets that are needed to work in this business. So what we're going to do is look at some promising practices for educational program development in the around rapid prototyping, incorporating additive manufacturing as part of engineering technology pathway, which is the technique we took in Florida, and also looking at some job opportunities for program graduates. So, okay, Mike?
That sounds good. Okay, we're headed to the next slide, and it's Slate's ET College Network.
Okay, let's see now. I've got to get in the mic mode here. So in Florida, Slate works with a network of colleges, and they're on the map to put everybody in a geographic frame.
Yes.
There's 11 colleges throughout the state that all have engaged in and are offering the engineering technology degree. We're going to talk about that a little bit, how it's set up and how we were able to put a new program up in place. Okay, next slide.
Yes.
And so we've identified this particular area as having a need for technicians, especially in some areas in the state. And the three schools that are circled here in St. Petersburg, St. Petersburg College, the State College of Florida in Manatee and Sarasota County, and the College of Central Florida in the Ocala region, that work together to develop what we have to do in Florida, which is define some competencies at the state level that what students and graduates would have to work in this field. St. Petersburg College took the lead and has probably the largest and most robust program at this time. This is 2 years ago that we started this effort. So we work with industries like and industry partners like Eric and some other companies we'll talk about later to help define some of these skill sets. And how we work with that in Florida is within this engineering technology degree. Our degree plan has just a regular 3 kind of components, Gen Ed, and we've defined a common core, and then a number of different specialization tracks. Okay, next slide.
Yes, we're on it, and it says AS Engineering Technology degrees, 60 semester hours.
And it has lots of words in the MSSC logo?
No.
No, one more. The one behind.
There we are. Thank you. I'm on it.
Okay. Okay. Okay, so here's the kind of the nitty-gritty details of that. We're going to just focus right now on number 3, which actually is the second year of the 2-year program. That is where they differentiate themselves depending on the industry sectors we're trying to support in different parts of the state. So everybody takes the first number 1 and number 2, the core and the Gen Ed requirements at their colleges, and different colleges offer different specializations depending on their local industry. So next slide.
Okay, we're there.
Oh, let's see. I'm expecting myself.
Oh, there's a little circle around the digital design and modeling feature there. Yeah.
Right. So when the need was identified, particularly starting in St. Petersburg, the frameworks developed and came out as a specialization or track under our EP degree as digital design and modeling. That's the name we've given to it. Probably in retrospect we may have named it something different, but that's what it was named 2 years ago, and that will probably stick for a while. We were trying to differentiate it from the traditional drafting programs that the state has. That particular set of frameworks goes down to architectural focus and construction. So that's one of the things we were trying to differentiate ourselves from, because we were really interested in product design and development. So our EP degree has this kind of a pathway cycle. We have lots of ways to, oh, next slide, sorry.
Okay, there. Okay, I'm looking at your blank pathway. Should I click?
Right. You can click, yes.
Okay, I'll click. Okay, now I've filled in year 1 and year 2.
Okay, so the 2-year degree program is there in the center of the slide, and in developing our program, we left it with flexibility in the second year there to add these different specializations as needs came up, as long as they were areas that fit under that had students and graduates that would also need the engineering technology core piece as well. So we left this opportunity with us, having worked with the Department of Education, to tell them that was our plan when we started this design, that we would be adding additional second-year programs. So adding the digital design and modeling to the existing framework was pretty straightforward for us as far as having a place to put it without having to actually develop a whole 2-year degree program. Okay, next slide.
We're there.
Okay, just looking at that particular piece, this is kind of another view of the striped slide a couple times ago, showing where the digital design and modeling track now fits on the way to getting a 2-year degree program in engineering technology in Florida. Again, it's one of 8 different choices. Additionally, in each of the second year of study for these associate degrees, we have, at the same time we develop the track, we develop the college credit certificate. Now, these are state programs. They have their own program number in the state system. They're a completion point for students. So it's a technical program of shorter duration, and all just the meat of the technical part of the program. So we develop those hand in hand with the actual chunk of the degree that's in the track. And so this one is called Rapid CT, and it happens to be 15 credit hours. It's called Rapid Prototyping and Design.
So for 18 plus 15, is that what I need to get it? Am I understanding that correctly?
Right.
Okay. Okay, good. Thanks.
So we're gonna, next slide, we'll show you the details for that.
The breakdown. Okay, here we are.
As it rolls out at St. Pete College. So now we're talking about, in that second year of study, the student may have taken, of course, ideally would have taken all of those first year things, and they would be taking in this program to get to that 24 credits. Additional AutoCAD. There's one AutoCAD engineering technology core. And then look at that, there's 3 SolidWorks courses.
Oh, yeah. Yeah.
Introduction, Advanced SolidWorks, SolidWorks Advanced Applications, and then a co-op and co-op experience, which was part of what required in all of our programs in Florida, and also some technical electives. So that would round out the 2-year program, building on, again, the technology core. And then go to the next slide, please. I'm going to move to the requirement from for the certificate. Remember, that's 15 credits. We're going to take 3 of these courses here, the ones that are now in red.
Yes.
On the next slide.
Yes.
Okay. And we're going to go to the next slide again, one more.
All right.
We're going to define what we have defined, the certificate, the 15 credit hour certificate as having to have those 3 courses plus the 2 additional ones you see on the screen, which is the SolidWorks simulation and design analysis, plus a course in rapid prototyping, really working on the end product of the design process that Eric just walked us through for the last half hour or so.
Yeah.
So in the certificate program, it's packaged. That's it. You have to take these 15 credit hours. If you remember, the degree program had 6 hours of technical electives. So in the engineering technology degree program, they could actually take some courses that were not so focused on SolidWorks, and that they wouldn't have to necessarily take those last 2 courses that are on the current slide. They could take some other engineering technology electives. But in the certificate program, it's very focused on the job, a particular job as described by the title, and we actually require just very specific courses for that. So a student can do this, 15 credit hour certificate, go off and go to work, and then come back and build on his or her degree if he wants to at a later time.
Right.
We call these in Florida occupational completion points. So the colleges get credit for students finishing this chunk of their degree program. Okay, so that's kind of the nitty-gritty of the academic piece for the program in Florida. Some of the job titles that that students may apply for. Again, this is an area where we really don't have a lot of SOC codes from the Department of Labor that don't fall outside of the engineering design, which is at a higher level. So these are regional titles that are used for the jobs here. We don't have, like I said, a COL SOC code, so but they would be something like a CAD tech, a CAD designer, design technician, or a rapid prototyping type designer.
Right.
Some of the requirements that the programs would have for setting this up, and what they actually have at St. Pete College as an example, in the software area, AutoCAD, SolidWorks. The rest of the softwares here go with the equipment, the CamWorks, MasterCam, and Modella. Go with the CNC machining, Modella with the scanner, I believe. And so you can see they've got 2 3D printers of a different variety and technology, different types than Eric was talking about earlier. They have the Dimension variety, and U-Print is a common, I think, in many of the community colleges around the country. So they do have noticed that they have that 3D printer, but they also, in this rapid prototyping area, they have a small CNC machine, because it's another way, and probably it's traditional way 20 years ago of getting some kind of prototype was to actually just machine your first piece. So they do some of that in this program as well, just to get the full scope of the skill sets there.
Can I interrupt you, Malone?
Sure.
I got a couple of questions, and I thought I hate to just throw this in right in the middle, but it's very appropriate for this slide. So what is it going to cost for a college to set up a program like this with equipment like this? I mean, Eric said printers range from $1,300 to $80,000, more or less. Can you give us a sense of what some of these things are going to cost?
Well, the 3D printer, the U-Print printer.
Yeah.
I think the entry-level one is just under 20,000 these days to get the whole thing set up to go. And I know that many of the colleges in Florida and some high schools as well have that particular one. It has a reasonable build space. It uses it doesn't use the powder as Eric described. It uses a plastic base. And he mentioned that technology. So that's about 20,000. The AutoCAD is institutionally purchased. I actually don't know what that costs for institutional license, which I believe is how that's handled. And I think that changes from site to site depending on how many programs actually use it. SolidWorks is pretty reasonable. Those guys seem to work with the colleges individually based on their needs for seats. And the little milling machine, I don't really know how much that was.
Whatever those are pretty easy.
Yeah. And then the computers, you have to have some high-end computers to do the design work.
Yeah.
The scanner, I'm not sure which scanner he's buying. I know he's got some bids out right now, or looking for bids right now. So he's probably looking for the milling bed for the kind of commercial one level that Eric was talking about earlier, and not the desktop little scan cheaper one. So that one I think he was talking about was 20,000 and 20 to 30,000 in there.
20 to 30. That's what I was going to guess.
Yeah. So not. I mean, I think typically you probably really need you need at least one printer to get really into that, and you probably need at least one 3D modeling software. Maybe I'm not that familiar with the SpaceClaim, but perhaps that would be an alternative for SolidWorks, especially starting up a program.
Yeah.
It may be more reasonable than SolidWorks as an entry level. And then, so I don't really think it's too bad. And I think in order to have a full program, you probably have to include courses that engage in the scanning technology as well as the printing technology and the design piece, all three pieces that Eric talked about, which is what they've just built up to. So in the St. Pete College's case, they actually started, they had a strong program in this SolidWorks for a number of years. The medical device manufacturers would go to the colleges, many of them in the Pinellas County near that college, wanting little prototypes. You mentioned the medical device earlier, and that's what they would go there to get them printed by the students. And the need just continued to grow, and they added a second course, and that was probably 4 years ago, in SolidWorks design. And then it's just kind of grown over the years to the point where it actually became a whole, part of a degree program. They invested in enough courses and more equipment and other software to support what was happening in the program. They didn't actually decide they were going to start a program and get $1 million grant or $500,000 grant and put it into place. It was a building process for this one.
Good.
And at the same time separating it from the architectural drafting. There was a point where they were both under the mechanical kind of drafting, we would have called it many years or not too long ago, versus the kind of construction drawing. Pictures were under the same umbrella, and as this became more and more popular and had a higher need in the community, and they developed more courses, then it became got its own identity. Okay, so let's see, a couple more slides here. So there's a few of the companies locally in Pinellas County that hire graduates from his from the program at St. Pete College. So when I asked for these company names, he said DSE is just DSE. It's sort of like Kentucky Fried Chicken. It's just KFC now.
I see.
That means. But both of those at a design and engineering firm over there, and they do make some products, but they're more into the prototyping area. TSE is actually a company that does a lot of production, and they do a lot of the modeling and prototyping in-house, as well as the ultimate production for other people. So it's kind of like a contract shop. And they use a lot of different technologies for the production as well. So they would have some that was a machine, and some that were actually built up in 3 in additive kind of manufacturing ideas. And the same is true for the gun barrel drilling. Sorry, as a design, they would ask somebody to do the design work, or they've got designers in-house that would do prototyping for their different products. Okay, next slide, I guess, is just a recap of where we started.
Yes.
That we wanted to look at some practices, some promising practices for educational program development in this area, and how we incorporated it into our engineering technology degree program as a track underneath the existing degree plan, allowing us to only have to develop 1 year worth of courses and not a whole 60 credit hours for the entire degree program. And we also looked at some of the job opportunities for the graduates of such a program. And
Lovely.
That's it. If anybody has questions.
Okay, we're going to ask our audience to go ahead and type in any final questions now. And while you are doing that, I know we have some that already came in. So while you're doing that, our presenters have offered their contact information. It's up on the screen now, and it's also included in the handout that you should have received. So while you're typing in your questions, we're going to take just a second to pull up a quick survey. We ask that you please take a moment to complete the survey while our presenters and moderator go over the final questions and answers. So with that, I'll turn it back to you, Mike.
Thank you, Laura. Hey, Marilyn, got a question about graduates that emerge from your program in this area. Are you able to track them as they go into the workforce? What does that look like? I mean, are they getting placed? Are they successful? Do you have any sense of that?
Well, I'm not actually in that college, but I do. I have the anecdotal data is I did ask Brad Jenkins about this before. He took off on spring break this week, and he said the ones that stay, yes, he knows where, he knows that they're stay geographically in the area. He knows that they're working, and that they're still working in their field. And I know one that's on his way to engineering college, an engineering program as well. So I think there's many of them actually get snapped up before they finish their degree, if they're in the degree program, or at the end of their certificate. I think that's pretty typical of a lot of our programs. And one of the reasons we have that little certificate built in there to try to capture those as completers.
Yeah, because you're under the same pressure we are, is to look at this completion agenda. So I think that was pretty interesting in putting that certificate in there to count it, so to speak.
Yeah, it's a technique that Florida has used for off and on for years, I should say. They go in and out of vogue, but there is a actual record of that certificate program. They're called technical college certificates, and they're supposed to be occupational training pieces. So it could be in any AS field, even in marketing, where you could take 4 or 5 courses, get a college level certificate, and then move that into, come back and do more, but actually have something that says, I took these 4 or 5 courses, and that are almost like short-term training, like incumbent worker training, perhaps, and in a different arena. So it's an interesting project. They've actually done this with the post-secondary vocational programs as well in Florida, where they've divided or sectioned out the longer-term programs, training for occupations in Florida, into smaller pieces, these occupational completion points, and give completion for finishing about a semester at a time for that particular kind of program. So it's I don't know if it's unique to Florida, but it's part of our culture here to capture that. It's a technique to try to capture them.
Good. Laura, why don't you go ahead and close the survey? I think that's been enough time for folks to participate.
Okay, 2 more questions if you'd like to.
Yeah, I will take them. I just want to reiterate one of the questions that came up, and that is to get a printer, one of the printers for academic use. We're talking about $20,000 for a decent level printer, aren't we?
Right. Give or take. I mean,
give or take. Yeah. What do you think, Eric?
Well, we offer the ProJet 1500, which can do like plastic-like material. It's a resin that's cured by DLP, so it's kind of competitive to the Uprint, the Dimension printers. The printer itself starts at 14.5.
Oh, okay, that's better.
Yeah, but when you get out the door, it's with materials and install and training and all that stuff, you're right around 20 grand. The
scanner is a separate deal from the printer, right? There isn't like a scanner built into the printer or anything like that.
No, there isn't. No, yeah, they're separate technologies, and those start. The Virtuoso has a great bundle package with RapidForm, and the scanner itself is $18,000, but RapidForm is the reverse engineering software, and so you get 21 seats with this bundle package. Normally a commercial seat of RapidForm is $20,000.
Yeah.
But you're going to get education discount. You're going to get 21 seats and the scanner, all installed, training, everything out the door for under $34,000.
Okay.
All right.
Good. How much time do we have? Oh, do I have time for one more question?
I'm sure. You want to take it now, or you want to take it at the end?
Oh, what are we going to do now? I see. You're going to. Why don't you go ahead and take us through this section? Thank you.
I was going to remind everyone that the webinar was recorded, even with the glitches. I think we'll still have a recording available, and recording slides and handout will be available on our website in our digital library at maytechnetwork.org. Keyword search webinar innovative manufacturing, and we will email all of you that information as well as soon as those resources are available. And if you enjoyed this webinar despite the glitches, or are a fan of Networks webinars in general, we'd like to introduce the next couple webinars that we have coming up. Mike, do you briefly want to kind of give a little short...
Yes, I do. The Minority Male Initiative is a program here at our own college that talks about keys to success of addressing underrepresented populations in general, with a focus on minority males. And this program has been running for a couple of years now. There'll be some students that are joining that webinar, talk about some of the issues that they face. On April 13th, we'll talk about earning credentials. And you just heard it today, where Maryland made a very distinct initiative to introduce a stopping point, a certificate, as a type of credential that a student could take into the workplace. And that's a big topic today with community colleges, and I think many of us know that. And finally, on April 20th is the Masters Series. And the topic here is called From STEM to STEAM, where arts has been added into the conventional science, technology, engineering, and math. And that's going to be presented by the noted speaker, Jim Brazel. So I think these will be very interesting opportunities for the future, Laura.
Thank you. Okay, and if you, since you did join the live version or attend the live version of this webinar, and if you would like a a certificate of participation for attending the live version, you can email m.bender@domail.maricopa.edu, and I'll put that address in the chat box in just a moment. And I believe Mike is going to ask one more question, and then we'll thank our presenters and our audience.
I will. Eric, thanks again for the technology side. To me was fascinating today. How do you feel, do you think that the laser sintering machines where they use the metal powders, are they competitors, or are they addressing a whole different thing? I'm just curious about that.
It's a whole different market that they're going after. I mean, it's very expensive. One of those machines by itself is well over $250,000 to $500,000.
Oh, I didn't know that.
The machine itself, and then the powder metals are very expensive too.
Okay.
So, yeah, little parts cost a lot to produce. So it's they're going for a different customer.
All right, very interesting. So, Marilyn, I certainly appreciate your coming here. Do you see the future for educational technology moving this way? You think other colleges in your Florida system will adapt programs like this?
Yeah, I think so. We have two that are looking at it right now. Is just maybe going into it at a slower pace than what I showed you, the kind of full-blown program at St. Pete. But the other two programs are behind that. Further behind in the development stage. I don't know that they're offering yet those kind of higher level courses or have the milling machine, for example. So I think there's still a lot, like Eric said, a lot of growth still in this industry, and I think there'll be lots of opportunities for students to get jobs. And the thing I like is it's a really nice connection between the kind of merging of the engineering and the technician place here, space and place here, where we used to have engineers doing a lot of this kind of work, and as the technology comes around, there's a need for our associate level of students to get involved at their level. So I'm looking forward to that.
I think it's a perfect ending point, opportunities for students in a pretty rapidly emerging industry. I'd like to thank you, Eric, very much, and Marilyn. Really appreciate your being on board today, and that officially concludes our webinar. Goodbye.
Thank you all for attending.
Thank you.